Welcome back, everyone. In this chapter, we are beginning Unit 3, which is all about right triangles and similarity. This first chapter is going to teach you about right triangle trigonometry, but first I want to teach you about the geometric mean. The geometric mean is when you take the square root of the product of two numbers. Remember, square root means to find a number that when multiplied by itself equals the number given. So remember, square root of 25, for example, means find a number that when you multiply it by itself equals 25. So I know that 5 times 5 equals 25. So the square root of 25 is 5. Also, product means multiply, in case you forgot. So for example, the geometric mean of A and B, the formula is square root of A times B. Let's do this problem together. It says find the geometric mean between 8 and 10. So I'm going to write G equals the square root of 8 times 10. Now I have a couple options on how to go about simplifying this. My first way that I could do it is multiply 8 times 10 to get 80. And then think, what perfect square goes into 80? The largest perfect square that goes into 80 is 16, and it goes in 5 times. The square root of 16 is 4. Whoops. This is actually a very common mistake, so I want to point this out. A lot of times after people take the square root of 16, they write that it's equal to the square root of 4. However, this is not true. Square root of 16 and square root of 4 are not the same. The square root of 16 is equal to just 4 because 4 times 4 equals 16. So I know the geometric mean between 8 and 10 would be 4 radical 5. Another way I could approach simplifying this problem is to break it down into its factors. So if I build a factor tree for these two factors, I see that I have factors that are repeated. I have 2 times 2, and again I have another pair of 2's. What this means is that I could multiply 2 times 2 2 times itself. So I can pull that out from under the square root. Any number that has its factor repeated. So since 2 is repeated 2 times, I'll pull it out of the square root 2 times. Any number factor that was not repeated, 5 in this case, must stay under the radical. Be careful because we don't need to include 4 because 4 was already broken down into 2 times 2. So do not include 4 in your answer under the radical. Only use the final factors. Now we can simplify this. 2 times 2 is 4. So we get the same answer, 4 radical 5. Please pause the video and try the practice problems below. Here are the correct answers. The first one was nice because it was actually just a perfect square. Now let's see how this has to do with a right triangle. So geometric mean theorem tells us that G is the altitude, which we learned about in the last chapter, altitude. Remember, it's the height of the triangle. But there's 3 different altitudes in the triangle. We are looking specifically at the altitude that's drawn from the right angle to the hypotenuse. So in this triangle, triangle ABC, the right angle is angle C. So I have to start the hypotenuse, I meant start the geometric mean, the altitude, from point C, and it goes to the hypotenuse, which is AB, the opposite side. So the altitude that I'm talking about is that one. The length of that altitude is the geometric mean of the length of the 2 segments on the hypotenuse. So you'll notice this altitude splits the hypotenuse into 2 sections, segment AD and segment DB. The length of the altitude is the geometric mean between A and B, the length of those two segments. We could write this as a proportion. A over G equals G over B. Sometimes this is how you might see geometric mean. However, if we multiply this, cross multiply A times B, and cross multiply G times G, which is G squared, we get G squared equals A times B. In order to get G by itself, I know I must square root both sides. When I square root both sides, I need positive or negative. I know that this segment CD has to have a positive length. So the length of G, again, is still equal to A times B, the geometric mean of A and B. Let's try using this in a problem. So previously, we would not have been able to solve this because we're missing, if we look at any of our right triangles, triangle JKL, we're missing two sides. Triangle MLK, we're missing two sides. Triangle LMJ, we're missing two sides. So we wouldn't be able to solve this with just Pythagorean theorem. So this is why it's helpful. I know that G equals the square root of A times B. Therefore, X is equal to the square root of 20 times 5. I can simplify this to square root of 100. So I get X equals 10. Now that I have the value of X, now I can go ahead and find the values of Y and Z. It doesn't matter which one I find first, whether I find 5 first, or, whether I find Y first or Z first. It might help you out to redraw the two separate triangles. So here I have triangle KLM, and this is triangle JML. Now I'll use Pythagorean theorem because I have two sides of a right triangle. So I know it's 5 squared plus 10 squared equals Y squared. And for triangle KLM, I should have 20 squared plus 10 squared equals Z squared. Remember, the hypotenuse of the triangle, the one across from the right angle, always has to be C in Pythagorean theorem. So if I simplify this, I get 25 plus 100 equals Y squared. Then square root both sides. I know that the perfect square 25 goes into 125 5 times. Whoops, on the previous line I should just have Y. Once I take the square root, it's just Y. The square root of 25 is 5. So I got Y equals 5 radical 5. For this equation, I'll square my 20 and my 10 first, combine like terms, square root both sides. I know that 100 is a perfect square that goes into 500. It goes in 5 times. The square root of 100 is 10, so I get Z equals 10 radical 5. Pause the video and try the practice problems below. I'd like you to try to keep your answers in exact form, which means keep them with the square roots if that applies. Do not simplify them to decimals, please. 3A, I'd like you to give me the answer to. 3B, your answer for X is 16, Z is 15, and Y is 20. You can check your work there. Now let's try using this in an application. So it says Zach wants to order a banner that will hang over the side of his high school stadium bleachers and reach the ground. To find this height, he uses a cardboard square to line up the top and bottom of the bleachers. He measures his distance from the bleachers and from the ground to his eye level. Find the height of the bleachers to the nearest foot. I've redrawn the triangle so it's easier to see. And I know that I need to use geometric mean to solve this problem. I know G equals the square root of A times B. So that means 10.5 equals the square root of x times 5.75. Now this is a little different because x is under the radical. This is like that previous practice problem. In order to get x by itself, I need to first get it out from under the square root. So I'll need to square both sides. The inverse of a square root is squaring. So whenever you want to get rid of a square root, square both sides. This gives me 110.25 on the left side, and the square root cancels out with the squared on the right side. So now I just have x times 5.75, so I can go ahead and divide both sides by 5.75 in order to get x by itself. The question said to round to the nearest foot, so when I plug this in, I get 19.17, but I'm going to round that off to 19 feet. Now, actually, before I circle that answer, that is the value of x. I need to go back and check what I'm trying to find the height of the bleachers. I did not find the height of the bleachers. X is not the full height of the bleachers. It's only from the top of the bleachers to this man's eye level. So in order to find the height of the bleachers, I need to take the value of x, 19 feet. Well, actually, let's use the non-rounded version and not round to the end, and add 5.75 feet, because that's the height to his eye level. When I add those together, I get 24.9, which now I can round to 25 feet. Finally, I'd like you to read this question and answer it, please. Aiden and Tia are finding the value of x in the triangle shown. Is either of them correct? Please explain your reasoning in 1 to 2 complete sentences. That's all I have for you today. See you tomorrow.